Okay, now last video we computed the expected value of two of the return of two assets. Now I'm going to compute the variance of the two returns and then the variance of the portfolio. Then I can use the summarize command again. Yes, I'm going to repeat this one to get the variance of each return. Then if I do the summarize and if I type return list, if I run these two commands, then I'm going to see that the variance, I have the variance here that is computed here. Okay, now I can capture that scalar in a scalar for me. Then why am I using these scalars and not using why am defining these scalars instead of using these because these are temporal scalars. Then I have to capture, I have to save the data in my own variables. If not, I can lose the data very easily. Then once I do this, I have the variance in my memory. Then I'm gonna capture it in a scalar that I am gonna name it. I'm gonna call var1. It's gonna be equal to r. I have to check the name. Exactly, the name is r var with capital V. Remember this data is case sensitive. Then capital V. Okay. If I have a minus mistake, I will have an error or empty values. Then I have to be careful with the name of the variables. Then now I store the variance of alpha in var1. Now I do the same, but now for the second asset, that is basically Electra, and I just changed by var2 and I keep the same name because now I have, when I run it, I will have now the data of Electra here. That is, if you see the first time, I have a different value. If I go back, I have 0.007 for the variance of alpha, and now for the variance of Electra I have 0.02, right? Then I have a bigger variance for Electra compared to the variance of alpha. Then it should be that Electra is riskier than alpha. Then once I have both variances, now I can compute the expected value of my portfolio. Then it's going to be, then I'm going to call it var p, is going to be equal to the weight I'm going to be allocating for stock 1 is 40%, right? If you remember the formula that is here, it's 40% square, right? 40% square. Then I can use the sign to square a number, the same as in Excel. Okay, now times, can just put it in parentheses just to make sure that I'm computing the value correctly, times the variance of asset 1 plus 0.6 raised to the 2 times the variance of portfolio of return 2. Now I have to add the term for the covariance. How can I compute the term for the covariance? Okay, before I have to use another command that is called core. That is correlate is the command. I can abbreviate it just with core, and then now I have to use the two return series. Since in my data set I only have two assets, I can just type r asterisk. Then that means that it is going to consider the two returns of the two assets. Then if I do this and with the option var, then if I run this one, I'm gonna get the covariance matrix of the two assets. Then instead of var is cov, the covariance. Okay, I got an error here. Var not allowed. That means that this is not the correct option. Then if you do not remember an option, just remember to use the help command. But I know that the option is called cov. Okay, if I run this one, then now I'm gonna get the covariance matrix. What has the covariance matrix? Here I have the variance of alpha in the diagonal terms, the variance of Electra, and in the non-diagonal terms I have the covariances. Then since I only have two assets, there is a simple 2 by 2 matrix. Then it's a symmetric matrix, because in this one that is empty, it has the same value, because the covariance of alpha with an electron is the same than the covariance of electron and an alpha, basically. Then this is the covariance term. Okay, then how can I know where this value is stored? How can I get that value? Remember, I'm going to use after this return list to know how Stata store, where Stata is storing the computations that were done by the previous command, right? Then return list is always run right after any command, then I can know where the data is stored. Then here I can see that this one is a matrix, then basically it's this matrix. How can I know the value of this matrix? Then it's just a matrix, then I have to type matrix list, is a command, and I gotta type the same name of the matrix, RC. Then matrix list RC, if I just run it, then I'm gonna have the actual value of the matrix. Then this is a matrix. A matrix is a set of columns, a set of vectors, right? It's a set of values. Then how can I get this value that I'm interested in? This is the value, if I see, is the row 1 and row 2 and column 1 of the matrix. And that's the way I can get that value, is using coordinates. But first I have to define another variable called matrix. I'm going to call it cov. It's going to be equal to RC. Now in this variable matrix, in this variable cov, I have the value of the whole covariant matrix. Now how can I get the value of this value, that is row number 2 and column number 1? How can I get that value? Now I get that value from, I have to add, if I remember the formula of the variance, I have to add 2 times the covariance. Okay, then it's going to be 2 times the covariance. Now how can I know that is the covariance between the two assets? Is covariance, that is a matrix. Then to get one value from the matrix, I gotta open a special parenthesis, right, a rectangular parenthesis, and I type the number of the row of the matrix, comma, the number of the column. That means that I'm getting only one cell of the matrix. That is basically the covariance, that is this cell. If you see this as a set of cells, like in Excel, then this is the cell that corresponds to the second row and the first column. Then you type first the rows, the number of the row, and then the number of the column. Then by doing this, I'm getting actually this value, okay, 0.0023, etc. Then now that I multiply by the covariance, now I have to multiply by the product of the two weights. That is basically times 0.4 times 0.6. Okay, and now that is the way I can compute the variance of the portfolio. Then I'm gonna run only this part and see what's gonna be the value. It says var1 not found, and that means that I have a mistake here. Then var1 not found. I didn't run this one. I'm gonna rerun it again from here until here. Maybe I missed running this line last time. Then now I have no mistakes. Okay, now I'm gonna go back, then I'm gonna display the variance of the portfolio. Basically I'm gonna display the risk, the standard deviation. Then the standard deviation of the portfolio is square root, this is a function that is square root of the variance. Okay, if I run this one, now I'm gonna know exactly that the variance of the new portfolio is 0.10, right? Then this variance of the portfolio should be less than the variance, than the individual variances of the two assets. Okay, if you see here, the variance of the standard deviation of one asset is 0.08, the standard deviation of the other asset is 0.14, then the standard deviation of the portfolio is a number between those two numbers. is a little bit more than the first asset, but less than the second asset. Okay. Now I'm going to stop here.